In this video, I'm going to show you how to create an animation in the Inovista Animator, which will be then used in a standard web page and uses basic JavaScript commands to update its data. Opening a web page, we can see an animation that updates when a drop-down is changed. The visual sketches out a glass outline, then presents the volume in the bar chart style, and finally displays the textual value. Okay, let's load a static image into the animator, a basic wine glass downloaded from Wiki Commons. Clicking on parts of the image opens up the item on the tree on the left, and vice versa. Selecting the editor image next to the element opens an option box which gives us the ability to change many aspects of the image. Here all I'm doing is hiding it. And then next we select the wine part of the glass and hide that too. To create new transitions for the whole or any part of the image, select the Edit option. Under Transition, then add New Transition. We generally have 5 or 6 transition types to choose from. Here I'll choose Combination. In Combination, I want the wine to become instantly visible after 1,000 milliseconds or a second. So I set a delay of 1,000 and a duration of 0. Then check Include Attributes and set opacity to 1, which means the wine will show after 1 second. Now we want the wine to slide up like a bar chart. In this case, I could use a combination, a mask or a clip transition. However, the best transition here is probably a clip. This will uncover parts of the image as it moves. So let's create a clip with a 1 second delay and a 1 second duration. Then we can set the clip percentage amount, for example 77 here, and the direction of the clip, in this case we want the direction of the clip to be up. Running that, we can see the bar chart effect. But to make it more interesting, let's add an easing effect. There are a whole range of easing effects available. Typically, in effects happen at the beginning of the animation and out effects towards the end. Let's try a bounce out effect and run that. Okay, to sketch out the outline, we need to use SVG dash arrays. So find the glass outline either in the image or on the tree and then open up the editor panel. The dash array and offset work exactly as they sound. Here though, we don't want dashes, we want to work with the whole outline. The number at the bottom indicates its length in pixels. So if we enter that value into the dash array and about half into the offset, we can see the outline's been pushed about halfway around. Entering the full length completely hides the outline. So to create the sketch, we select Edit for the glass part of the image and create a new combination transition. The combination transition contains the attribute section, which in turn contains the data array section. Here we re-enter the length of the outline but set the offset to 0. This means the data array will push the border around to simulate a sketch. Okay, running the animation now, we see we have the sequence of transitions in probably the order that we want them and at the time length we want them. To show the text, we'll use another combination transition. So go back and select the edit next to the text item in the tree and create the transition. Make the transition length a second, as the animation is already 2 seconds long. So we enter 2000 for 2 seconds in the delay so that the text appears towards the end. Then include the attributes with the include checkbox and enter the text that will be displayed. And of course, we want to make the text visible, so enter a 1 in the opacity section. So if I run that, we can see we now have our animation pretty much as we want it to be. So that the animation can be set dynamically by external events, we add variable values for transitions that will be data-driven. We can select these transitions either from the node drop-down or from the editor panel below the image by clicking on the relevant item. To set the glass level, change the clip value percentage to a textual name. To update the text, select the text display transition and enter a variable name in the text attributes. As this is a text item, we also need to click the checkbox below to show that it is in fact a variable. To test this, move to the variables section at the bottom and enter test values against the newly created variable names. These names will be exported with the animation and used by any external tools. Running the project, we can see the variables are correctly changing the animation. If you are using external tools and you want the image to be automatically resizable, go to the image size item within the image project and make sure it's set as a percentage. To export the image, including its animation, click on the Export button in the toolbar. This will open the Export Files section where the standalone image button is found. Click this to generate the animation. A download link will be added below, but the animation will also be saved on the cloud. Click on the toolbar Cloud button to access any saved files. We can also copy the SVG and the code that has been created. Open the Copy Source section and click the standalone image button in there. This will open a pop-up containing the code. Select the Copy button and then paste this into a file editor. Remember to ensure that the file ends in -anim.svg when you save it. Details on the required object and code snippets are available as a link in both sections. Clicking opens a dialog which contains the JSON object that will be used as a data source, as well as the functions that are available in the API. Click the Copy button to copy either the object or function. Now let's look at creating an HTML file which contains the data-driven animation. You can of course use any editor you're happy with, but here I'm editing the text in Visual Studio. I've added a script section in the head tag and set an object in the format shown in the animator. Regarding data in this example, it's hard-coded, but most implementations will use some form of external data source. The important point is that the format matches the data object that was defined in the previous section. Then the initialize function copied from the animator is added. Note that the parameter for the SVG object has already been set. As data object is the same name as the name being used, that also does not need to be changed. And as we're not repeating the animation, we can remove the last parameter. Scrolling down, we see a select drop-down with year values and a call to update anim when a value is changed. The update anim function gets the year selected in the drop-down. Pasting in the refresh function, copied from the animator, we set the data object value as the year selected in the drop-down. We do that here by using the selected property of the data object. At this point, we're going to add the animated image and we'll add it under the select drop-down. There are three ways we can do this. The first way is to add it as an object tag. Under object, set the type to images/svg+xml and set the data to the path of the image downloaded from the animator. If necessary, set the required width and height of the object. The next way we can do this is by adding an image tag. Now in the image tag we must have a class which is called Inovista-image and set the source again to the path of the SVG file we downloaded and if necessary the height and width. Now the final way we can add the image is to go to the Inovista Animator into the copy source section and then copy the standalone image. And what we're going to do here is paste it inline directly into this file here. One aspect of pasting the SVG inline is that the animation will in fact run without the need for a web server. In the head tag, make sure the required libraries are linked. We always need D3 in Inovista.svg.js. Other libraries may be required depending on usage, for example when morphing shapes. Check the download page for more information on this. So when we open that web page in a browser and we refresh the browser, we see that the animation is also refreshed and rerun. Equally, when we change the selection in the drop-down, we see that the data object's been updated, passed to the animation, and rerun. So now we've created a data-driven animated image for a web page. Please check out some of the other videos at Inovista.com showing the wide range of animations that can be created with the Animator.